Tours 28, you are clear for takeoff.
Knots. Stop! Don't hammer the brakes. Don't hammer the brakes.
137 people are on board this British Air Tours flight. Within minutes, nearly half of them will be dead.
This should not really have happened.
Evacuate! Evacuate!
The aircraft didn't even get airborne. It didn't run off the runway, and yet still 55 people were killed.
For investigators, it's a familiar routine. Reconstructing the final moments inside the cabin, analyzing the wreckage and the flight data recorders. In the end, they turn to a psychologist to help them figure out how a survivable emergency turned into one of British aviation's most horrific disasters. It's just before 6 in the morning on August the 22nd, 1985. Manchester's airport is coming to life. The first flights of the day are being prepped for departure. British Air Tours Flight 28 is scheduled to take 131 passengers from Manchester to the Greek island of Corfu. British Air Tours is a division of British Airways, specializing in low-cost flights to vacation destinations. It's a chilly morning. A slight breeze is blowing, ideal flying weather. Most of the passengers on this early morning flight are traveling on vacation. Lindsay Davis is heading to Greece with her boyfriend, Charlie Thixon.
All right, let's go.
We'd been going out with each other for a year, and that's one of the reasons we were so excited about it. You know, it was our first holiday together.
Captain Peter Terrington is in command.
I was the senior training captain on the fleet.
First Officer Brian Love is being trained by Terrington.
He was going to perform the takeoff and landing as part of his training.
All right, Captain? Yep. Briefing then, Brian. Airfield emergencies, you handling the aircraft. What are the 4 things you're going to stop for?
Fire, failure, configuration warning, or you shouting stop.
Okay, so you bring the thing to a stop, and I'll take over the aircraft and leave you to deal with the emergency. I'll liaise with ATC, okay?
If you've talked about the possibility of an emergency and talked over what you will do, then if it actually happens, it's easier to recall those items.
Okay, Brian, start 2.
Starting 2. Oil pressure rising.
Okay, go on.
4, 25, 26, 27, 28, 29. 129 plus 2 on board, Captain. All strapped in, doors are closed and automatic.
Thank you, Arthur.
The crew is flying a Boeing 737. It takes just 4 minutes for the plane to reach the foot of the runway.
Tours 28, you are clear for takeoff.
The 737 has 3,000 meters to get to takeoff speed. The engines are pushed to high power.
I was sitting by the window, looking out of the window. Everything was normal. The plane was going quite fast.
80 knots.
Check.
We heard a dull thud, which sounded as if it came from outside. I was really keen to see what was going on outside, but couldn't see anything.
Captain Terrington needs to act fast.
Stop.
And the immediate reaction was to stop. We were quite a few knots below our decision speed, so I very quickly closed the throttles and applied reverse thrust.
We could feel the aircraft slowing down, and Arthur said, "Oh, I think we've blown a tyre," and I didn't know, so we just waited to hear it.
Don't hammer the brakes. Don't hammer the brakes.
I thought the tyre might have gone and would cause damage to the undercarriage if we braked too strongly.
Probably nothing. I wouldn't worry.
And just assumed that maybe a tyre had burst, so I wasn't really alarmed at that point. My thought at that time was, oh, okay, we're going to get off this plane and probably have to move all the luggage onto another plane and take off.
Soon, passengers on the left side of the plane see the real problem.
I could see orange flames inside the back of the engine. And at that point, I thought, it's obviously not a burst tyre, that wouldn't cause that, and this is perhaps something a bit more serious.
Let me by. I'm not staying there.
But at that point, I knew that I wanted to get off the plane, and I wasn't happy at all. I knew that there was a fire, and I just wanted to get away from the fire.
Smoke is seeping into the cabin.
Please sit down.
My nearest exit was at the back. I didn't want to go to the back because the smoke was coming in there. So I decided in my mind that I was going to go through the front. I said to Charlie,
Come on, we're going.
and that's when I started going towards the front of the plane.
Stop it. 28 Mike, we are abandoning takeoff. Looks like we've got a fire on number 1.
Looks like there's a lot of fire.
Thank you.
Plane on fire, runway 24.
From where he's sitting, Captain Terrington can't see how bad the fire is. He needs advice from the tower.
We have to get the passengers off.
I would do by the starboard side.
Terrington decides to pull off the runway.
Evacuate to the starboard side, please. Fire drill, engine number 1. Shutting down 2.
Evacuate! Evacuate! Please stay calm.
Before the flight crew leaves the cockpit, they must complete a 15-step checklist.
Parking brake.
Set.
Speed brake lever.
Down.
But time is running out.
We had an evacuation checklist, but it was 4 pages long, and the last item was to get the passengers off.
Engine and APU fire warning switches.
This didn't cover my problem at all.
On the 737, there are 4 cabin doors. The 2 in the back are covered in flames and smoke, leaving only 2 for 137 people. Then a mechanical problem eliminates one of those.
Well, Arthur was opening one right, and it was really trying to open. It was really hard to open.
The back of the cabin is filling with smoke. It's making breathing difficult. Passengers rush forward.
It just seemed to go on forever before they started evacuating. And that's when I thought, I'm not going to get off, it's going to blow up with all of us on it.
Engine and APU fire warning switches.
Right now, all 137 people on board are alive. But with every second, their odds of surviving are decreasing. Flight 28 is becoming a death trap. The jammed door on the right side of British Air Tours Flight 28 leaves the crew no choice. They must get the passengers out from the side of the plane that's burning.
soon as we opened the door, the fire service were already around, shooting foam up the slide that came into the galley floor. We wanted to start to evacuate the passengers, but there's a bit of a bottleneck and nobody was coming forward. The aisle is quite narrow where the galley is, and they were and then they were pushing forward, and I could see this boy that was really sort of pushed against the wall. He couldn't get out, so I pulled him by his T-shirt, had the yellow T-shirt on, and he sort of tumbled forward, and after that, everybody sort of just tumbled in behind him. And we just directed him down the slide.
Jump! Jump! Jump!
In training, they tell you to, bring people to the door, and you tell them to jump.
Desperate to get people off the plane quickly, the purser returns to the jammed door. After several attempts, he manages to force it open.
The only time I turned around was to make sure that Charlie was following me.
See you out there?
One thing I did see when I looked back was people going to the front, towards the front of the plane where the seats are, and pushing the seats forward, folding them down as they went along. So people were trying to rush forward from the back. The chute was open and people were just jumping up straight onto the chute. As I got to the bottom, I didn't look back at all. I was just wanting to get off.
Dozens of passengers have made it off the plane, but there are still many more inside.
But it was smouldering and it was black, thick black smoke. And Charlie had said that after you'd gone, this black smoke came down, he said, and everybody was screaming and panicking. He said people are going to die in there.
Standby power switch.
Captain Peter Terrington and his first officer Brian Love are still aboard the burning airplane, and they still haven't completed the steps required to evacuate.
There was 4 tons of fuel coming out of that aircraft wing tank.
Okay, go, Brian. Go, Brian.
I could see quite a lot of flames.
Completing the checklist would put their lives at risk.
We did as many items as we could, and then we both went out of the flight deck window.
There are no more passengers at the exits, so Joanna Toff decides to see if anyone else is left in the cabin.
And the smoke was you could touch it. It was so thick, and you could take it was awful, really.
Go!
There was a young girl just a bit further down in the cabin, but she was really disorientated. I mean, I suppose we all were, really. We just didn't have any idea what was going on. I just brought her down to the slide. She was taken off then. The fireman was telling me to come on, and I was thinking, well, I've not finished, we've not finished yet.
When Toff re-enters the cabin, the thick smoke makes it as hard to see as it is to breathe.
It was really dark and quiet. I'd never seen anything like it. And I could see the light from the door anyway by then, so I knew where the door was.
The smoke forces Toff to abandon her search. Just minutes after pulling off the runway, British Air Tours Flight 28 has been consumed by fire.
We got out of a flight deck which was relatively intact, and when we turned round on the ground, we saw a complete wreck of an aircraft, and it had happened in a matter of seconds. It was dreadful.
54 people are dead. Another would die in hospital.
There was nothing wrong, really, with us. We thought nothing physical wrong with us. But our lives changed, you know, just in those few hours.
I couldn't breathe. I was virtually out the door. I couldn't breathe then.
The smoke was coming in and everybody just stood up and ran out. It was just a mad panic getting out.
Because when the smoke came, you just couldn't see anything at all. Couldn't see anybody.
It takes 125 firefighters more than 2 hours to put out the fire. News of the disaster soon spreads around the world. British Prime Minister Margaret Thatcher flies to Manchester to visit the scene.
When we get a terrible air crash of this kind, everyone is appalled and shocked. Every single aspect of this accident will be thoroughly investigated. It has to be.
This is the 4th major commercial air disaster of the year. In June of 1985, an Air India jet exploded over the Atlantic Ocean. 329 people were killed. Weeks later, 137 people died when a Delta Airlines flight crashed at Dallas-Fort Worth Airport. And just 10 days before the Manchester crash, the deadliest single aircraft accident in history. Japan Airlines Flight 123, a fully loaded 747, slammed into a mountain, killing 520 people. British Air Tours Flight 28 adds 55 new victims to the list of casualties. 1985 is now the deadliest year in the history of commercial aviation. The flying public is getting nervous. Britain's Air Accidents Investigation Branch sends a team to Manchester to unravel the events that led to the catastrophe. Among them, Stephen Moss. He'll be inspecting the plane's engines.
This should not really have happened. The aircraft didn't even get airborne. It didn't run off the runway, and yet still 55 people were killed.
Chris Prothero is also on the team. His focus is on the fire.
We were aware from initial reports that the fire had entered the aircraft very rapidly as the aircraft came to a halt, and that was a focus for me.
It doesn't take too long for Stephen Moss to figure out where the trouble started. He sees damage to the plane that was not caused by fire.
Well, the first thing we noticed clearly was the hole in the underside of the wing. And right next to it was a gaping hole in the side of the engine. It seems that one had led to the other.
To get a plane loaded with passengers off the ground, you need to generate massive thrust. That power is created when air travels through the front of the engine to a series of compressor fans. It's then ignited, and the exhaust pushes the plane forward. Something had clearly gone very wrong with Flight 28's left engine. Investigators look for clues on the runway and in the cabin, hoping to discover why so many people died.
Entering the cabin for the first time, there was as with all aircraft fires, there's an overwhelming and pungent smell. Burning plastic, burnt fuel, burning material had dropped down onto seats, and so the aisles were filled up with the remains of overhead lockers. A scene of devastation.
The damage in the cabin is revealing. It's almost completely charred up high, but is relatively intact down low.
It was clear that there had not been flashover in this particular case.
A flashover occurs when the gases in an enclosed space become so hot that they ignite, incinerating everything around them. The way Flight 28's cabin is charred tells Prothero about the nature of the fire.
Many of the seats squab, cushions, even things like the emergency evacuation cards, which are just plastic laminated cards, were pretty much undamaged. You could have wiped them off and put them on another aircraft and nobody would have known they'd been in this accident, whereas at the upper levels in the fuselage, there was a great deal of heat damage, and this is not a characteristic of a flashover.
The fire in the cabin had been severe, but should not have been catastrophic. This leaves investigators with two questions. Why did so many people die? And what caused the fire? The answer to the second question may be outside the plane, lying on the runway. Investigators find a large piece of dome-shaped metal along the plane's path. Stephen Moss can see it's from a piece of the engine called a combustor can.
It looks like there'd been a separation of the can from the front end from the back end.
The combustion chamber of the 737's jet engines contains 9 combustor cans. It's where fuel and air are mixed and ignited, so each can needs to withstand intense heat. Moss suspects the fractured can somehow blew apart and destroyed the plane's left engine.
It had struck an underwing fuel tank access panel and put a sizable hole in that, which directly led to the release of a vast quantity of fuel.
Proving the piece of the combustion can penetrated the wing is easy. It fits neatly into the hole in the wing.
This was clearly, if you like, the root cause of the accident.
The engine on the plane is a Pratt & Whitney JT-8D. For Moss, that's of grave concern.
At the time, was probably the most widely used jet engine on commercial air transport in the world. And it was obviously pretty urgent that we try and find the cause of this one in order to prevent other aircraft having the same problem.
There are tens of thousands of combustor cans in service around the world. One of them erupted in Manchester. Stephen Moss needs to find out why it failed. And fast. Investigators looking into the deadly fire on board British Air Tours Flight 28 study the plane's maintenance log. They discover the combustor can that ruptured had previously been repaired.
We needed to look at that repair and how effective it was.
During a routine inspection a year and a half earlier, mechanics had found small cracks in some of the combustor cans.
It was certainly not uncommon to find fatigue cracks in the cans. They're operating in a high temperature environment. The manuals give various schemes for repairing these cracks.
Investigators find mechanics repaired the cracks according to a procedure laid out in the engine repair manual. They welded them closed. But the crack on can number 9 was unusually long.
The overhaul manual did not give any limit on the length of crack that could be repaired, and it was a longer crack than had been experienced before. It was still repaired.
After the repaired cans were put back in the engine, mechanics had no way of knowing the weld didn't effectively seal the crack. That's because the cans can't be inspected while the engine is on the plane. Since the repair, there were 11 reports of slow acceleration from the engine that exploded in Manchester. A damaged combustor can could have been a reason for the problem. But troubleshooting guides available to mechanics in Manchester didn't list that as a potential cause. Instead, Pratt & Whitney offered other ways to fix the acceleration problem.
It didn't seem to ring any great alarm bells with them, if you like. They'd seen it before, and it had never turned out to be anything serious.
So mechanics in Manchester made minor adjustments to fix the plane's idle speed and kept the plane in operation. Cockpit voice recordings reveal that the crew of Flight 28 was aware there was a problem with slow acceleration.
Slow acceleration on number 1 engine day before yesterday.
I was on the flight, yes, sir.
Engineers signed off on it.
But the log entry led Captain Terrington to believe that the problem had been fixed.
A comment in the tech log for the flight before the last one, that the engine was slow in accelerating. It wasn't apparent as a serious problem because the engineers had done some work and the aircraft had been flying the previous day with no problems.
The idle speed adjustments didn't fix the real problem, the cracked combustor can. And it reached the breaking point on Flight 28.
Stopping. 28 Mike, we are abandoning takeoff.
Evacuate! Evacuate! Please stay calm and don't panic.
If the airline had inspected the cans, I think there is no doubt that they would have seen the problem.
Investigators now know the origins of the Manchester disaster. The welded crack in combustor can number 9 gave way as Flight 28 sped down the runway. The front of the can was ejected from the engine and put a hole in the underside of the left wing. That led to a huge fuel leak onto the damaged engine, which caused the fire. Engine fires are not uncommon. The body of a 737 is insulated with fire-retardant material to protect the cabin. Investigators still don't understand how a fire outside the plane spread into the cabin as quickly as it did. Fire Inspector Chris Prothero finds part of the answer from viewing photographs of the plane as it sped down the runway.
It was clear from these photographs that there was a very dynamic phase to the fire whilst the aircraft was at speed on the runway, which produced this energetic, turbulent, sort of blowtorching type of fire, visually anyway, trailing behind the aircraft.
A press photo from the day of the crash leads Prothero to a new theory.
The photographs of the aircraft that appeared in the press showed the left thrust reverser deployed. The general impression that one got visually from that photograph was that the thrust reversers had effectively blowtorched fire against the side of the fuselage, and that, if you like, was the explanation as to why the fire had penetrated so quickly. That photograph and the implications of it actually therefore loomed quite large.
Stop!
There are several ways to bring a speeding jetliner to a halt. One is with the brakes.
Don't hammer the brakes.
Another is with the engine's thrust reversers. Thrust reversers redirect the exhaust from the jet engine forwards. This helps slow the plane down.
It looked as though the thrust reversers had simply blown this big fire on the left of the aircraft directly onto the side of the aircraft, directly onto the rear fuselage.
That would explain why the fire destroyed the cabin so quickly. It now seems possible that Captain Terrington made the fire worse by trying to slow his plane down. But Prothero has two good reasons to doubt his theory. One is the location where charring from the burning exhaust gas, or efflux, was found.
The efflux impinges on the fuselage further up, closer to the roof, the crown skins of the aircraft. So actually, the penetration that we had low down did not fit with that.
And the other reason is, by the time the thrust reversers were deployed, the left engine had already exploded. But to act as a blowtorch, the engine would have needed considerable exhaust.
We did calculations to confirm that the residual thrust from that engine would not have had the energy to have this effect. That confirmed that the thrust reversers couldn't actually have played any role, or significant role anyway, in the fire's severity.
Clearly, something other than the thrusters had caused the fire to spread so quickly. Prothero looks more closely at the data. After examining weather reports from the day of the accident, he finds the answer.
The wind was the main factor that determined the severity of the fire in terms of its attack on the outside of the aircraft, how rapidly it penetrated the aircraft, and it also affected the conditions inside the cabin.
Believing he had blown a tire, Captain Terrington made a fateful decision.
Stop it. 28 Mike, we are abandoning takeoff.
Well, when we heard the thud and we closed the throttles, it was my assumption that we were going to turn off the runway, clear the runway, ask air traffic for an engineer to come out and check the tyres.
Like a highway, an airport runway has a series of exits. Captain Terrington chose one called Link Delta.
So we've got a fire on number 1.
When we got the additional information of a fire warning, the brain was already programmed to carry out the stop.
The crew had been aware that they had a fire, but didn't really appreciate at the time the nature of the fire, the severity of the fire, so they had turned off the runway.
Captain Terrington turned his plane to the right and brought it to a stop. He couldn't have realized that doing so would make the problem far worse.
There was a crosswind, a slight crosswind, from the left side of the aircraft that was carrying the fire that was burning from the fuel that was pulled underneath the left wing. It carried that fire aft, rearwards, and took over and under the rear fuselage, in between the wing and the tailplane.
The wind wrapped the fire around the back of the plane and into the cabin.
If there'd been no wind at all, I think the situation would have been very much more benign.
Investigators have discovered how the fire started and the conditions that caused it to penetrate the cabin. Now investigator Ed Trimble must solve the biggest mystery surrounding the Manchester accident.
Here we had an aircraft which had aborted the takeoff for good reason. It had taxied off and stopped in a taxiway in an expeditious manner, and yet 55 people had lost their lives. So there was a big question as to precisely why that had occurred.
Investigators learned that most of the dead were not found in the worst burned parts of the plane. Autopsies will point to the real killer on Flight 28. Of the 54 people who died in the cabin, only 6 had suffered serious burns. All the rest died from smoke inhalation. It seems the smoke in the cabin was particularly lethal. Survivors tell investigators that the smoke was unbearable.
The smoke was really black, and it was almost touching. It was really weird.
And they say the effect of that was shocking. Immediately you took one breath of the smoke, you began to feel debilitated, and you knew that if you took another breath or two, you weren't going to make it.
At the time of the Manchester accident, the effects of fire on an airplane had been well studied and understood, but the effects of smoke were not. To figure out what made the smoke so toxic, Trimble decides to recreate the fire that burned on Flight 28.
We were trying to model not only the gases which were produced, but also the kind of threat levels which were produced.
The smoke that filled the plane was from materials burning inside the cabin. The foam in the seats, the wool in the carpets, and the plastic overhead bins all release poisonous fumes. Those conditions are recreated by burning those same materials. Trimble discovers the passengers on Flight 28 inhaled smoke that contained a deadly blend of poisonous gases, including high levels of carbon monoxide and hydrogen cyanide. Now he desperately needs to find out if there's any way to protect airline passengers from that kind of smoke.
So it seemed to me pretty clear that unless we could protect people's respiratory systems from the assault from such combustion gases, there was little that we could do to improve survival chances from aircraft fires.
Over the course of 5 weeks, investigators run dozens of tests, experimenting with different filters. They burn nearly a quarter ton of material to create the necessary smoke. Their dramatic conclusion: it may have been possible to save passengers' lives.
There was not the slightest doubt in my mind that in these situations, in an aircraft cabin, if it is being assaulted by combustion gases, your chances of survival are vastly improved if you have smoke hood protection.
British Air Tours Flight 28 had only enough smoke hoods for the crew. They were never used. Trimble's research indicates that smoke hoods for passengers could have saved lives.
There were hoods available, both of the filter type and the breathable gas type, which can provide a very high level of protection to people in these circumstances.
Many of the passengers on Flight 28 would have survived with a few more minutes of breathing time.
It was in a blink of an eye, you know, from the time, you know, we stopped on the runway, you know, just within a few minutes, you know, it was all over, really.
A full Boeing 737 is designed to be evacuated in less than 2 minutes. So even without additional time, more of the passengers on Flight 28 should have been able to get off. To discover why so many people never made it off the plane, investigators turned to an unlikely source for the answer. By law, airplane manufacturers must prove their planes can be evacuated quickly and safely. When the 737 was introduced in the UK, Boeing demonstrated that 130 people could get off the plane in just 75 seconds.
All public transport aircraft are certificated to the same criteria, and that is that the total complement of passengers must be capable of evacuating from the aircraft using half the exits in the aircraft, it's generally one side or the other, within a maximum of 90 seconds.
But 90 seconds after Flight 28 came to a stop, most of the passengers were still on board.
The reason why the evacuation in Manchester wasn't achieved in 90 seconds is because the conditions in a real fire evacuation are completely different from the certification conditions.
The certification evacuation is conducted in clear conditions, with no smoke that reduces vision and overwhelms passengers. Within minutes of coming to a stop, Flight 28 filled with thick black smoke.
As soon as the smoke began to spill into the rear cabin and then flow forwards, essentially that induced immediate panic in those who were so affected by the smoke, because their respiration, I mean, the typical comment was, I took one breath of smoke and I felt as though my lungs were solidifying. You can imagine under these conditions that people have got to get away from the smoke. And people did this by basically clambering over the seats and other people in front of them.
In less than 5 minutes, what should have been a survivable accident turned deadly. To prevent future tragedies, Britain's Civil Aviation Authority decides to learn more about people. Helen Muir is a psychologist and a leading expert on how airplane design can influence survival. She's asked to study the behavior of passengers on Flight 28 to figure out why so many died.
What we had to learn to do was to design the aircraft interior so even if we had what we might say was dysfunctional behaviour in totality, we could accommodate the needs of individuals and their desperate rush to get out.
Muir configures a cabin to duplicate Flight 28 and fills it with volunteers. Then, to have them act as though the plane's on fire, she offers money to the first ones off.
And that produced behaviour that was quite unbelievable. People went over seats, they went round, past each other, all sorts of things. And indeed, when survivors from the actual Manchester accident came and saw the videos, they said, yeah, that's how it was.
The evacuation of Flight 28 was slowed by the fact that passengers became jammed in the bulkhead opening separating the main cabin from the galley. Investigators discover the logjam was created by the design of the Boeing 737. The bulkhead opening was 22.5 inches wide, just enough for one person to fit through.
But what they wanted to know was how much wider would they have to make it for people not to get stopped and blocked. We were trying to do as much as we could to recreate the situation which had happened at Manchester and then to systematically vary the aircraft interior to see what changes would improve the situation for passengers.
Muir's tests showed the narrow bulkhead opening created bottlenecks that flight attendants had to constantly clear. Increasing the width to 30 inches greatly improved the movement of passengers.
But we showed through repeat testing that if you changed the minimum gap from 20 to 30 inches, you would dramatically improve the speed at which people could get out and you'd reduce the likelihood of people falling and slipping and so on.
As a result of Helen Muir's work, a recommendation was made to increase the space between the bulkhead walls to 30 inches and introduce strip lighting to help guide passengers to exits even when they are blinded by smoke. Muir also found a way to improve cabin safety without redesigning the cabin.
Please sit down.
She conducted research on the behavior of the cabin crew in emergencies and found that passengers get off a plane much faster with a highly assertive crew.
It's because we don't want people really making their own decisions. We want people to do exactly what the cabin crew or the procedures state, and we don't want people hesitating, particularly at the door.
Helen Muir's research prompted manufacturers to redesign cabins to make them safer. But one safety feature remains controversial: smoke hoods. Ed Trimble believes they should be mandatory on all commercial flights.
Without a doubt. Without a doubt.
Helen Muir is less convinced. She's studied how smoke hoods affect passenger behavior and is worried they would slow down the orderly evacuation of an airplane.
We know you've only got literally 1.5 to 2 minutes for everybody to get out. What we don't want to have is something which is difficult to put on, and so it slows people getting down.
The most important lesson of British Air Tours Flight 28 is that seconds matter. It's now universally accepted that it takes 90 seconds from the first sign of fire before it becomes unsurvivable. The passengers on Flight 28 lost valuable time when the starboard side door jammed. The investigators determined that the slide mechanism deployed too early, preventing the door from opening. There was a flaw that led the slide container's lid to jam if the door is opened too quickly. After the Manchester accident, Boeing quickly redesigned the system so that couldn't happen. But the recommendations made by the AAIB weren't adopted quickly enough to save lives 6 years later. In 1991, a Boeing 737 slammed into another plane on the runway in Los Angeles and caught fire. Many of the 22 people who died were overcome by smoke before they could get out. But in 2005, the crash of an Air France jet in Toronto showed how much has changed since the Manchester accident. All 309 people got off that plane in just 90 seconds. No one died. Some major changes to commercial airliners
All right, the door's open.
came about because of a flight that never left the ground.
That's the only way I can resolve it, with the death of 55 of my passengers. The fact that flying is now safer.
I can't imagine anybody, you know, doesn't wish that it hadn't happened. You know, despite what's been learned and despite maybe the subsequent lives that have been changed, you know, you'd give anything for it not to have happened.
For investigators trying to solve a plane crash, the most important tool can be the black box. It records every detail in the cockpit.
Look at this. Where's Charlie at?
And tells investigators about vital conversations.
Damn, it's starting to rain.
Northwest 255, runway 3 center, clear for takeoff.
But in the crash of Northwest Airlines Flight 255,
I have never been to an accident of that scale.
it wasn't what investigators heard on the tape.
TCI was on set.
It was what they didn't hear.
It was checked.
That would lead to an astonishing conclusion. Detroit, Michigan, August the 16th, 1987. It's 8 p.m. and the city is sweltering. 25 kilometers from downtown, Detroit Metropolitan Airport is one of the busiest airports in the United States. More than 1,100 airplanes use its 4 runways each day. Today, one of those is Northwest Airlines Flight 255, bound for Phoenix, Arizona. Captain John Mouse is in command. A Las Vegas native, 57-year-old Mouse is a veteran pilot. His first officer is 35-year-old David Dodds of Galena, Illinois.
Why don't you tell them we're ready to go?
Both have years of experience on this type of aircraft. The MD-80 is also known as the Super 80 and is the second generation of the DC-9.
The MD-80 was quite a bit longer. It had more powerful engines, so it could carry more people. For that reason, it was a better moneymaker for the airlines than the DC-9 was.
Look at this.
The sky between Detroit and Phoenix is filled with storms. Several are moving quickly towards the airport.
There's a line here.
For the crew, it's been a long day.
They're about 25 miles wide.
Well, if we get out of here pretty quick, we won't have a delay.
They've already flown from Minneapolis, Minnesota, to Saginaw, Michigan, and then Detroit. Phoenix is their next stop on the way to Santa Ana, California.
If we wait till after the storm's here, there'll be delays going over Waterville.
If they're delayed by weather, they may not make their final destination.
Let's get out of here before it starts raining.
The plane's 149 passengers are also eager to leave. Paula Sheehan and her family have been visiting relatives. They're heading home to Arizona. Her daughter Cecilia is only 4 years old.
Looks like bags are all in.
Why don't you tell them we're ready to go?
Ramp 255 and Delta 15.
Flight 255 is running half an hour late.
Northwest 255, clear to go.
Okay, we're cleared to push.
Let's do the checklist.
Brakes.
Set.
Windshield heat. It's on. Boost pumps. Unit 6. Cabin pressure controller. Checked. Auxiliary hydraulic pumps and pressure. On and checked.
Yeah. It's starting to rain.
To beat the storms, they need to leave immediately.
Sign beacons. Go on. Before start checklist is complete.
Flight 255 begins moving from the gate to the runway.
Northwest 255.
But because of the weather,
Northwest 255, now exit at Charlie Runway 3 Center.
the ground controller gives them a last-minute runway change.
Okay, to Charlie for 3 Center, Northwest 255. Charlie for 3 Center, right.
Okay.
Ladies and gentlemen, we're currently number 1 for departure. We should be rolling in a couple minutes. Let attendants be seated, thank you.
Blacker than hell out there.
Where's Charlie at?
By the time they get to the new runway, they're 45 minutes behind schedule.
Northwest 255, runway 3 Center, clear for takeoff.
Within 17 seconds, 65,000 kilograms of passengers and aircraft hurtle down runway 3C. But moments before liftoff, Mouse discovers he can't engage the auto throttle.
We'll stay on. TCI's on set.
His computer isn't in takeoff mode.
They're on now.
Okay.
Clamp. 100 knots.
At 313 kilometers per hour.
V1. Rotate.
The pilots angle the plane's nose up for liftoff. Then something else goes wrong. Just under 50 feet from the ground, the aircraft begins rolling from side to side.
Power lifeguard copter 102.
It rolls left and strikes a light pole. Out of control, Flight 255 slams into the ground, skids along a highway, and disintegrates when it hits an overpass.
I prayed that everybody made it, but I thought it was just a small plane because it happened so quickly. I didn't know it was a bigger plane, and it was just awful.
Saw the plane come through the viaducts in a big fireball.
Well, we got dispatch. It was a rainy Sunday night.
And then he said there's an airliner down, and our mood kind of just changed. And the one guy looked at me, Dan, and said, well, I hope it's a small one. When we pulled up, we saw the cockpit and the word West written on the fuselage, and we looked at each other, and he said, it looks like a big one.
There's a trail of scorched bodies and debris more than a kilometer long. Just minutes after impact, paramedic Tim Schroeder is on the scene looking for survivors.
I've never been to an accident of that scale. We were struck by the magnitude of what we were seeing, the large scale of it. It was almost overwhelming.
From the little that's left of Flight 255, it is unlikely they'll find anyone alive.
And I buddied up with Dan, and we both started entering the wreckage. It was probably a minute went by, and Dan actually heard a noise. He asked me a couple times, you know, do I hear anything? And I said no. And then finally I heard it, and it was more like a faint cry. When I turned my head to the right, I saw an arm underneath the seat.
1, 2, 3, lift!
She was covered in some blood and some soot.
Somehow, 4-year-old Cecilia Sheehan has survived the crash. But she's badly injured. Tim Schroeder races her to hospital.
We have a 4-year-old girl found alive in the wreckage. She has a very weak pulse.
If Cecilia survived, perhaps others have as well. Rescuers spend hours looking through the wreckage for more survivors, but their efforts will be in vain.
We actually covered anything that was a body or a body part with a yellow blanket. It was just nothing but like a sea of yellow blankets, basically.
Northwest Airlines said 154 passengers and crew aboard the plane died in the crash.
Both Captain Mouse and First Officer Dodds are killed in the crash. 2 other people died when their cars were hit by the plane. This is the second deadliest airplane disaster in US history. Recovering in hospital with serious head wounds is Flight 255's lone survivor, 4-year-old Cecilia Sheehan. Despite her injuries, doctors say she will live.
Maybe God was on her side that night.
Within hours of the crash, investigator Jack Drake and his team from the National Transportation Safety Board begin looking for clues. Drake is a former Navy pilot who's been involved in hundreds of crash investigations.
You know when you're at a crash site because you get this combination of burned plastic and kerosene, and sometimes combined with fire retardant foam that has its own distinctive odor. You know you've arrived when you smell it.
Drake and his team treat the crash site like a crime scene.
Our team consisted of 12 or 13 specialists, some of whom go to the site and some of whom do their work elsewhere.
They set out to examine every piece of wreckage to discover what went wrong.
They have responsibilities for looking at different parts of the wreckage debris and do qualitative analysis of those parts. We always look for the recorders first. They're frequently referred to as black boxes, although they're usually orange. The information is usually well protected because they're encased in a steel box that is both heat resistant and crash resistant.
Since the 1960s, commercial jetliners have been required to carry flight data and voice recorders. The CVR was first introduced in Australia following the 1960 crash of a Fokker F-27. The devices must be able to withstand an impact of 3,400 Gs and temperatures as high as 1,100 degrees Celsius. The The cockpit voice recorder is intact, but the flight data recorder suffered some damage in the crash. They may hold the only clues that can help solve this accident. Both recorders are sent to the NTSB lab in Washington, D.C. John Clark is Drake's flight performance engineer. His first task is to make a map of the debris left behind by Flight 255.
When I first started seeing the wreckage, your mind immediately starts turning to sorting out where it hit, how it hit, not where the wreckage ended up, but those first few inches where the airplane was coming down.
Clark looks for ground scars and other impact marks, and interviews witnesses to piece together where the plane fell and how.
And that kind of gives you a sense of those last moments, what the airplane was doing when it hit the ground.
Clark begins to understand the final moments of Flight 255. According to witnesses, as it lifted off, it couldn't climb and flew in a nose-high position.
E1, rotate.
That could indicate that the plane didn't have enough power to get off the ground, that it didn't have enough speed, or that high winds prevented it from lifting off. Witnesses provide investigators with a critical clue.
You saw fire coming from the engine.
Several, including an air traffic controller, saw flames coming from the plane's engine before the crash. The engines become the first focus of this investigation.
They look for evidence of an internal failure.
The plane suffered an engine failure.
Investigators soon learn that less than a month earlier, one of the plane's engines was damaged when it was hit by a foreign object. It was repaired and was being monitored by mechanics to see how it performed. The team studies the remains of the engine for clues that it had either caught fire or shut down on takeoff. Despite what the witnesses saw, they find no evidence of fire or of a massive breakdown.
The information suggested that the engine operation had been normal.
Plan, 100 knots.
The flames were the result of the fuel tank rupturing after the plane hit a light pole. The fire didn't cause the crash. If Drake and his team are to solve this mystery, they need to be certain about what happened in the last few seconds before Flight 255 crashed.
Well, I think probably the best physical evidence is what was on the flight data recorder. The flight data recorder doesn't tell you about weather, it tells you about aircraft parameters, aircraft performance essentially, second by second, even at quarter-second intervals in some parameters.
But NTSB technicians can't recover all the information from the recorder. They send it to the manufacturer to see if they can recover the lost data. While he waits for news about the flight data recorder, Jack Drake looks more closely at the weather on the night of the crash.
There was some convective or thundershower type activity that had moved through the area, and its impact on the accident required a lot of analysis.
Drake wonders how the storm affected Flight 255. He listens to the cockpit voice recorder for clues. He discovers the menacing weather was a concern to the crew.
Let's get out of here before it starts raining. Jesus, look at this.
Drake sees that there were several storms along the flight path, and they were getting closer to Detroit.
There's a line here, and a line between these two, and another one here about 25 miles wide.
Thunderstorms can create a very dangerous threat to pilots.
Since there was severe weather in the area, we always worry about microbursts.
Microbursts occur when columns of air shoot down to Earth. As a plane passes through, winds batter it from all directions, making it difficult to control.
In a microburst condition, you can get very shifting winds and also vertical winds that try to push the airplane into the ground. So you can get loss of airspeed, a very rapid rise in airspeed, and then also actually push the airplane toward the ground. And it requires very aggressive flying on the part of the flight crew.
This unusual weather condition had killed before. In 1985, a microburst brought down a Delta Airlines flight in Dallas, killing 137 people. At the time of the Detroit accident, there was no device at airports to accurately detect microbursts. Instead, pilots relied on reports from other crews. Jack Drake discovers that 27 minutes before liftoff, Captain Mouse and First Officer Dodds received such a warning.
Ground, this is 722. You just had a microburst out here. The dust just exploded down there.
Investigators suspect that a microburst may have slammed Flight 255 to the ground as it tried to lift off.
It was right after departure when the accident occurred. If they had struck a very strong microburst, that would be a candidate for one of the possible causes.
Satellite images taken at the time of the crash and weather data from the airport's sensors show that there were storms near the airport at the time of the accident. But there's no evidence of a microburst.
Wind and rain, but nothing that could be a microburst.
Around the time of the crash, the airport's sensors did record a dangerous gust of wind on the runway, powerful enough to set off alarms in the tower. Upon further investigation, Drake discovers that Flight 255 was still at the gate at the time of that alarm. So the winds couldn't have brought the plane down.
Sign beacons.
But they did have a huge effect on Captain Mouse's flight plan. The crew's pre-flight dispatch package stated that they would take off from runway 21 left. But with the sudden change of wind direction, ground control sends Flight 255 to runway 3C, the shortest of 3 available runways.
Northwest 255, now exit at Charlie runway 3 center.
Okay, out to Charlie for 3 center, Northwest 255. Charlie for 3 center right.
Okay.
Controllers try to have planes take off into the wind. The additional wind flowing over a plane's wings gives it more lift and helps it get off the ground. Taking off into the wind is safer, but taking off on the shorter runway now means First Officer Dodds must recalculate the plane's takeoff weight.
There's a runway change. You have to determine if the weight of the aircraft will permit it to accelerate and climb out safely. And this varies depending on the length of the runway, temperature, altitude of the airport.
Perhaps First Officer Dodds made a mistake in his calculation.
44.4. How can we do that like for a full airplane?
If he did, it could explain why the MD-80 wasn't able to make it off the ground. Runway 3C simply wasn't long enough. Using calculations based on average weight of luggage and passengers on board, Drake's team confirmed Dodds' estimate. The plane weighed 144,047 pounds, well below the allowable limit for runway 3C. It should have been able to get off the ground. Drake's investigation has hit another dead end. He and his team are running out of possibilities. Until technicians can decode the damaged flight data recorder, the team must rely on the physical evidence that's been found at the crash site. But when investigators study the cockpit's center console, they're forced to consider an almost unimaginable cause.
Is this the way it was found?
To get the plane off the ground, the flaps on the wings should have been extended to the 11-degree position. But the way the flap handle is damaged suggests the plane's flaps were retracted when it crashed.
The pin had left a mark. This happens because the aircraft comes to a very sudden stop and the handle jangles around, and it's a metal-to-metal contact that's exaggerated by the impact.
Well, stay on.
That indicator was that the flaps were zero or fully retracted, and the slats were retracted as well.
Flaps and slats are extensions that slide out of the back and front of the wing. They make the wing bigger, which increases the amount of lift they can provide. They must be extended for takeoff.
If the slats are retracted, and for the most part, with today's modern jets, the airplane is not capable of flight. It's not capable of flight.
If the crew tried to take off with the flaps retracted, it would be an astonishing blunder.
B1, rotate.
But a pilot who was lined up directly behind Flight 255 on the runway is certain the plane's flaps were extended.
And you're sure the flaps were extended?
Pilots in other aircraft that were close to the point where the takeoff had begun were telling us that they thought the flaps and slats were deployed to a normal position.
Investigators can't be sure whether the flaps were extended or not. The clues they need lie somewhere in the sea of debris recovered from the crash site. Eventually, investigators find the evidence they need inside a section of the plane's left wing.
Each component of the slat system has its own drive system, and one of those was interrupted by the light pole that passed through the wing. 18 feet of the left wing was severed.
The cable controlling the slats was sliced in two when the wing hit the light pole. Based on where the cable was cut, investigators can tell whether the slats and flaps were extended or retracted.
It severed two cables, and if you lined up those two severed ends, it corresponded with the slats being in the full retracted position.
It looks increasingly likely that the crew never extended their flaps. Only the damaged flight data recorder can verify this. Fortunately, technicians have finally been able to rescue all its data. A digital history of Flight 255's performance until the moment of impact.
I knew that if we had a good recorder, we were going to get data back. The flight data recorders in combination give you that time history that goes together with the physical evidence or physical damage.
As expected, the FDR confirms what the evidence has been showing investigators.
Flight data recorders told us that the flaps and slats had not been extended.
It's a major breakthrough. Drake now knows what brought down Flight 255. But the flight data recorder doesn't answer a more troubling question.
So, why weren't the flaps deployed?
For some reason, a seasoned crew forgot one of the most basic steps involved in getting an airplane off the ground.
Switch the colors.
2 months after the crash, Northwest Airlines Flight 255's sole survivor, Cecilia Sheehan, is released from hospital.
We can't be sure why the little girl survived. She's a very little girl buckled into a big seat. and she was more protected than adults that might have been sitting around her. But she was very lucky.
Jack Drake needs to know what contributed to the death of her family and all the other victims. He finds an important clue on the cockpit voice recorder. It shows that the last-minute runway change caused confusion in the cockpit.
Once the aircraft began to taxi,
blacker than hell out there.
West 255, no exit at Charlie Runway 3 Center.
other activities were introduced that had the potential to cause distractions.
Did he say 3 Center?
3 Center, yeah, that's why I was thinking we had to go that way.
I was thinking 2-1.
Well, they made a wrong turn, which might have been confusing because they had to go a different route.
Where's Charlie at?
Right at the end of this ramp.
I think Charlie was...
No, it is Charlie.
You sure?
I think so.
The crew got lost on the way to runway 3C.
Ground, Northwest 255. I guess we went by Charlie. We're going to 3 Center right.
Northwest 255, affirmative. Make a left turn at Foxtrot.
They finally got to the runway 45 minutes late.
Ladies and gentlemen, we're currently number 1 for departure. Should be rolling in a couple of minutes. Flight attendants, be seated. Thank you.
But Jack Drake finds something missing on the CVR. It seems the crew overlooked a very important step.
We're okay for the center runway, aren't we?
Damn.
Before they got lost, the crew of Flight 255 performed a number of checklists. But possibly due to the confusion of the runway change, they seem to have completely neglected the taxi checklist.
They apparently didn't consider the checklist, and key in the checklist is the configuration of the aircraft for departure, and the flight data recorder showed that was never done.
There are hundreds of small steps for a crew to take to get a passenger jet off the ground. Most of them are covered by checklists.
The checklist is a means by which you ensure that important items are positioned or done properly.
Transponder.
Instead of doing it by memory and having the possibility of a lapse of memory.
Brakes.
Flight crews use a very rigorous and regimented procedure of following the checklist.
Pressure control.
Verify that each switch, each dial, each lever is in the proper position before taking the runway for departure.
The first item on the taxi checklist is flaps.
One of the things that would have been included in their checklist was to configure the slats and flaps for low-speed flight.
But because they didn't run the checklist, the crew never set their flaps to the takeoff position.
I think Charlie was...
No, it is Charlie.
You sure?
I think so.
They hadn't done this checklist at the time they normally would, and as the activities piled up that were potential distractions, they were further and further away from the point at which they would normally perform that function. Their mindset was probably that they had completed it.
The pilots got an indication that their plane wasn't properly configured. During takeoff, they couldn't activate the auto throttle because their computer wasn't in takeoff mode. Another step covered by the taxi checklist.
Won't stay on. TCI's on set.
This should have alerted them that they didn't perform the checklist.
If it had occurred to them at that point that we might have missed something else on the checklist, that could have led to a rejected takeoff.
They're on now. 100 knots.
Okay.
Apparently that didn't happen, and so the takeoff was continued.
With disastrous results. An alarm should have sounded when the pilots tried to take off with their flaps retracted. But for some reason, investigators can't hear it on the cockpit voice recorder.
When it activates, it alerts the crew that the aircraft is not in a configuration that's safe for takeoff.
Maybe it went off, or we just can't hear it.
The investigation team is determined to find out why the takeoff warning didn't sound. Technicians analyze the cockpit voice recorder for more clues, and they find something unusual.
They picked up some enunciations on the CVR that were not correct.
Stall. Stall.
This warning is alerting the crew that the plane is about to stall. But it should be coming from 2 speakers in the cockpit.
Stall.
Technicians notice it's only coming from 1.
Stall. Stall.
As the airplane lifted off, there was a stall warning, and it has a typical characteristic of a sound like stall all, because there are 2 enunciations, and the purpose of that is to provide redundancy. But that redundancy wasn't there. We had a single stall. I went to an MD-80 sitting on the ramp at Detroit, and a captain took us through the process of checking out to demonstrate those different sounds.
Let's start with the config warning.
The takeoff configuration warning is what would have alerted them about the flaps and slats.
Flaps. Slats. Flaps.
Can we get the stall warning to sound?
Stall all. Stall all.
He activated the stall warning system by a test switch, and it said stall all.
The voice on the left channel is slightly different from the voice on the right, as it should be. But that's not what Clark heard on Flight 255's voice recorder.
Can you make it sound like this?
Stall. Stall.
To get a singular stall, he had to pull power to one side or the other. And one way he demonstrated that is he pulled the P40 circuit breaker.
A circuit breaker is the electrical switch that protects the circuit from damage caused by overload. The P40 circuit breaker is an important one in this investigation. It handled both the failed takeoff warning and the stall warning systems.
What struck me was, he said, I hear people doing it. I, of course, don't do it myself, but let me show you how. And he reached around behind him, around behind the seat and down low and pulled the P40 circuit breaker without looking. And then when he ran the stall warning system, we got the singular stall.
Stall. Stall.
It's a major clue. Clark could only reproduce the strange-sounding stall warning by pulling the same circuit breaker that's connected to the takeoff warning. This tells investigators that the breaker was tripped when Flight 255 tried to take off. Then John Clark notices something else about the P40 circuit breaker.
You could see smudge marks around the decals on each side of the circuit breaker. It looked like finger marks where oil had built up and dirt and grime over the years. So it told me that that circuit breaker was being used routinely by a lot of pilots.
Can you tell me why that is so worn?
It turned out that the takeoff configuration warning could be a nuisance to pilots.
If you're doing a single engine taxi, you have to push the throttle up further to get a power to taxi, and you would set off the takeoff warning system. And so they would pull the circuit breaker to silence it. It's irritating. It's a warning. It's meant to alert you. And if it's going off routinely all the time, it gets on their nerves. And so apparently pilots were routinely silencing those takeoff warnings.
Investigators suspect that the crew of Flight 255 tripped the breaker to avoid the irritating takeoff warning. And then, with the added delay from the runway change and the impending storm, they proceeded to take off without doing the taxi checklist. That might explain why the alarm didn't sound when they tried to take off with their flaps retracted.
We don't know if the pilot did pull that circuit breaker on that particular flight. There was certainly one error and the potential for two. I think that the extensive use of the circuit breaker because of the smudge marks around the circuit breaker and the pilot's statements, I think it's highly likely that he did.
It appears the downing of Flight 255 was caused by pilot error. Now investigators can accurately piece together what happened that night in Detroit. But it would take another shocking accident for the airline industry to learn its lesson. Jack Drake's team has discovered what caused the crash of Flight 255, but cannot prevent it from happening again. 1 year later in Dallas, Delta Flight 1141 tried to take off without their flaps extended. The investigators who had been working on the Northwest crash are stunned.
I was very frustrated to learn that another airline had done the same thing in a different aircraft type about a year later.
The Delta crash would uncover potentially deadly flaws
Before start checklist, battery.
in the checklists commercial pilots are trained to follow. The Delta and Northwest crashes killed 170 people and had eerily similar causes. In both disasters, the workload in the cockpit increased.
Jesus, look at this.
Northwest 255, now exited Charlie Runway 3.
If we get out of here pretty quick, we won't have a delay. Auto land.
And in both, the pilots failed to perform vital elements of their checklists.
It is very unusual for a crew to not perform a checklist. They have done it hundreds upon hundreds of times.
Brakes, windshield heat is on, cabin pressure controller is checked.
The normal procedures were a little bit out of the norm, and as a result, it got overlooked.
To prevent this from happening again, aviation officials turned to a government agency that knows the importance of clear procedures.
4, 3, 2, 1.
NASA.
So they're in there, ready to go. All right.
Jack Drake and his team wanted the US Space Agency to help create checklists that decrease the odds of items being skipped. Asaf Degani was a research scientist working with NASA. After the accident, he took on the project of improving a flight crew's pre-takeoff procedure.
We looked for any research that was done on checklists or procedures in general, and in fact, we couldn't find anything.
So Degani had to start from scratch. But there are dozens of different checklists to examine. Most of the ones on Flight 255 were printed on a single card. They listed the tasks the crew had to carry out, but didn't give them a way to keep track of what was and what wasn't done. At the time of the Northwest crash, there were several types of mechanical checklists in use. The US Air Force used a scrolling checklist. Once a checklist item is completed, the pilot scrolls to the next one. American Airlines used a system that allowed pilots to cover up completed items with a plastic slide, so only the non-completed items would be displayed. Asaf Degani set out to see firsthand how pilots were using checklists. He wanted to make it less likely for them to make mistakes. He sat in cockpits and observed 42 different crews in action. Degani concluded that many checklists were badly designed.
There's a certain flow by which you go about checking things, and the idea is to prevent a case where you're doing one thing here, one thing there. A checklist should have a certain flow, which is a logical flow, and not one which is kind of random.
Go, and they're ready, and they're going through there.
Degani also found a much more serious problem with checklists. If pilots are interrupted, they sometimes forget where they left off.
Transponder checked, and
turned on.
And there's many cases where people would do A, B, C, D, E, an air traffic call would come, they'd have to respond to it, and that's an interrupt.
Northwest 255, now exited Charlie Runway 3 Center.
They would go back to the checklist and skip a certain item and continue on the list, assuming that the whole list was done. People were very concerned about that.
To ensure no steps are missed, airlines train their pilots to return to the top of a checklist following the interruption and start over. Again, Asaf Degani sees a problem.
And we found that if checklists are very, very long and meticulous, that's overburdening the crew, and they sometimes would not want to start again from the beginning.
To address the problem, Degani suggests changes across the airline industry.
One of our recommendations from the study is to try to take long checklists and chunk them to small pieces so that if an interruption happens, then doing another 4 or 5 items, it's not a big effort as opposed to doing 20.
Degani even made recommendations about the typeface that airlines use, so they can be more easily read by pilots. Perhaps the biggest advance to checklists is the move from paper to computers.
Since at the time computer technology was coming into the cockpit, it made a lot of sense to think about the electronic checklist.
Today, Degani and his team are studying smart checklists that keep track of checked items. They provide pilots with a visual indication of where they are on the list, and in some cases verify that the task has been correctly carried out.
Electronic checklist shows you which item was completed and which item was not.
Computerized checklists are now slowly making their way into the cockpits of commercial airplanes. They make it far less likely that an accident like Northwest 255 could happen again. The FAA also ordered a modification to the alarm system of all commercial jetliners to prevent nuisance alarms. The takeoff warning was redesigned, so it could not sound unless the plane was actually taking off. Jack Drake went on to investigate hundreds of accidents over a 26-year career with the NTSB. The crash of Flight 255 taught him a valuable lesson.
This one is a worldwide example of the importance of following checklists and configuration being completed correctly on every takeoff. And so it became something that was a part of the training curriculum in virtually every airline around the world.
The case of Northwest 255 is no different. It's a series of events, runway change, task saturation, an overlooked checklist, a failed takeoff warning system. Put all of those together, those links in a chain, and you end up with the accident. If you were to break any one of those links, the accident wouldn't have happened.
Flight 255 will also be remembered for its lone survivor, Cecilia Sheehan. She's never spoken publicly about the death of her family. But she's stayed in touch with the people who rescued her that day.
She's full of life, and the conversations we have, it's more about, her sports and her husband and her vacations. She just said maybe one day she'll come out and tell the world what Cecilia is doing.
It's the first public demonstration of the world's most sophisticated passenger jet.
Okay, you're at 100 feet there.
100.
The Airbus A320 is being introduced to the world.
Mesdames et messieurs, votre attention s'il vous plaît. L'Airbus A320 arrive.
That introduction turns into a fatal calamity.
30. Get beat. 30.
It could not possibly have come at a worse time for Airbus. The crash was a major embarrassment.
There's enormous pressure on investigators. If Airbus is to survive, they must find the answer to one crucial question.
Was it the pilot or was it the plane?
It's 2:30 in the afternoon on June the 26th, 1988. An unusual charter flight prepares to depart Basel-Mulhouse Airport in France, near the Swiss border.
NTIs.
Captain Michel Asseline is one of Air France's most distinguished pilots.
On.
Though only 44, he's the head of pilot training for the company's newest plane, the Airbus A320. It's only the third of its kind to roll off the assembly line. Captain Asseline flew this very aircraft from the factory in Toulouse just 2 days earlier.
I was in charge of the launching of the 320 in Air France. The company used me to promote the aircraft. The speeches to make, I was constantly on the television, on the newspaper.
Air Charter 296 would like to roll, please.
Asseline's first officer, Pierre Mazière, is also a senior Air France pilot.
Air Charter 296.
He's invited 2 off-duty flight attendants to come along for the ride on this special flight. The aircraft is booked to perform a low-altitude flyover at a local air show. There are 130 people on board this A320, which is unusual for an air show demonstration flight. They have no luggage. For some, it's their first time on an airplane. There are even children, like 7-year-old Mariama Barry, unaccompanied by their parents. After the flyover, they will be taken on a sightseeing tour around Mont Blanc, the highest peak in Western Europe. Most got their tickets as promotional gifts from a local bank and newspaper. Jean-Marie Schreiber is a young reporter covering the launch of the new plane.
As a journalist, I was thrilled to be on the flight, to have a chance to see how people reacted inside the plane.
Another journalist aboard, Jean-Claude Boche, has been busy recording the event.
As I got on the plane, I thought, great, this is going to be an unforgettable experience. And it really was unforgettable.
The A320 is the first civil aircraft to use fly-by-wire, a cutting-edge technology that computerizes flight controls. The system had previously mainly been used by the military.
On the fly-by-wire system, the pilot essentially flies the computer, and the computer flies the aircraft.
Fly-by-wire alters the relationship between pilot and plane. It gives computers the ability to override human inputs to prevent pilot error. The A320's flight computer won't let its human operators do anything it determines to be dangerous. Airbus has become the first civil aircraft maker to embrace this technology. It hopes this will give it an edge over its longtime American rival, Boeing. In its first public presentation, Airbus has a lot on the line.
Okay, tell me what you want in terms of speed and altitude.
Okay, then takeoff, light turn. We go nice and easy to find out things.
We tried to demonstrate the capability of this aircraft. To say we wanted to show off, not exactly. We wanted to make a good job, and we were sure to make a good job.
Once we identify the airfield, we extend flaps to 3. We'll do the flyover at 100, landing gear out, and you just leave it up to me. I'll give it alpha max. Done it 20 times.
Okay.
Captain Asseline is planning a breathtaking maneuver. A low-altitude, nose-high flyby at alpha max. This is the slowest a plane can fly without stalling.
Ladies and gentlemen, Hello, and welcome aboard this Airbus A320, which was put into service just 2 days ago. We will soon be taking off for a short sightseeing flight, which will start from the Aviation Flying Club, and then we'll be flying around Mont Blanc. I wish you a very pleasant flight. That's done.
ACF 296Q, clear for takeoff. Runway 16.
We're rolling. Takeoff. Go.
Parameters normal. 100.
100.
It's already requesting climb. You see that?
Yes, that happens. I know the bug.
V1. Rotate. Gear up, flaps 1. After takeoff checklist completed.
It's only a 5-minute flight to Habsheim Airfield, where the airshow is being held. For this sleepy Alsatian town, the airshow is the highlight of the summer.
The airshow drew more than 5,000 people. There was significant interest from the public.
The airfield is so small, its coordinates aren't stored in the plane's navigation database, so the pilots must find it by sight.
You're at 8 nautical miles. You'll soon see it. There's the highway.
We leave the highway to the left, don't we? No, to the right of the highway.
It's slightly to the right of the highway.
There's the airfield. You've got it, have you?
The pilots have spotted the airfield late. They will have to hurry to descend to the planned altitude for the flyover at the airshow. A crowd is forming at the runway.
Air Charter 296, good afternoon.
Habsheim, hello. We're coming into view of the airfield for the flyover.
Yes, I can see you. Cleared. The sky's clear.
Gear down.
Okay, we're going in for low altitude, low speed flyover. 296.
Roger.
Flaps 2.
Quebec November Hotel, I'm saying Fox Echo 984.
Okay. 984. Put in 984. Flaps 3.
Flaps 3.
That's the airfield. You confirm?
Affirmative.
Flight 296 makes a gentle turn to line up with the runway. The pilots must now lose more altitude and speed to get into position for the flyover.
200. 200.
Mesdames et messieurs, votre attention s'il vous plaît. L'Airbus A320 arrive.
Okay, you're at 100 feet there.
100.
Watch it. Watch it.
The aircraft is now at the planned altitude. For Asseline, this will be the most delicate part of the maneuver. He must keep the plane in a stable position with the nose up, but not too high.
I looked at the ground and said, look, he's not high enough, because you could see the grass right out your window.
Okay, I'm okay there. Disconnect auto throttle.
He disables one of the plane's safety features so that the computer won't speed up the slow-moving plane. Only now, Captain Asseline sees a danger that threatens the lives of everyone on board. The A320's low-speed flyover at the Habsheim airfield is suddenly not going according to plan. There's a forest in the path of Captain Asseline's plane.
30.
Takeoff, go around power.
He selects the highest thrust setting and pulls back on the controls, expecting the aircraft to pull up. But the plane keeps dropping.
Can't be!
J'ai commencé à voir par le hublot des branches d'arbres.
I started to see through the window tree branches. I was astonished. You can imagine being on a trail in a large vehicle, a bumpy trail, driving at 80 or 100 kilometers an hour, and you're shaking from all sides. It was like that. I was saying to myself, the plane has to stay in one piece, because if the plane stays whole, we'll be okay. If it breaks up, we're done for.
S'il casse, c'est fichu.
Still full of fuel, the right wing of the jet is sheared off. The fuel ignites immediately on impact.
We stopped very quickly. And on the ground, I broke my seat, just because I was holding very firmly. I broke my seat, and I could see lot of flames all over. But about 20 meters high flames around the cockpit, smoke coming from everywhere.
The first officer is badly injured.
And he has a lot of blood. And even with the full harness, he hit something in front of him.
What the hell have you done?
I don't know. I don't understand.
There was a moment of silence when the plane finally stopped.
Incredibly, the fuselage is still in one piece. Everyone has survived the impact, but they're not out of danger yet.
Alors là, je me penche.
So I lean to the right, and I see red flames. The windows were red. And I think, we held together, but we're going to burn to death.
Mais on va mourir brûlé.
Then we heard somebody say, get out, there's a fire.
Sortez, sortez, il y a le feu.
Evacuate the aircraft. Hurry, I'll deal with him.
Only 2 exits can be used for evacuation. The rest are engulfed in flames. But thick branches block one of the doors, making evacuation difficult. In the chaos of the cabin, some passengers struggle with their seatbelts. Marie-Françoise Froche is one of the last passengers to leave her seat. She comes across Mariama Barry, who's trapped in her seat.
Mariama
Barry, she was 7, 8. After the accident, people pushing toward the exit pushed on the backs of the seats, the backs that folded over her, and then she was trapped by her seatbelt. No one saw her. She was forgotten.
On l'a pas vue, on l'a oubliée.
But it's too late. Both are overcome by smoke before they can get off the plane. In the cockpit, Captain Asseline struggles to get his injured first officer out of the burning aircraft.
I took him from his seat and belt him, carried, I don't know how, and I put it in a slide. When the passenger, all of them, the last one, was out of the plane, I saw my crew. They told me, Captain, they are all out. I couldn't believe it.
But the crew is wrong. Not all the passengers have made it out. Marie-Françoise Froche, Mariama Barry, and another young boy are dead. In addition to the tragic loss of life, the accident is a PR disaster for Airbus.
The crash could not possibly have come at a worse time for Airbus. They were trying out this new concept, which they had touted very widely as a new level of safety for civil flight. And here's a pilot going and crashing one. For those who actually saw the accident, and it was broadcast on the news media throughout the world the same evening that it happened, there was amazement. The crash was a major embarrassment.
Investigators from France's Accident Investigation Bureau are on the scene of the crash within hours. They need to know why this demonstration flight ended in disaster. They recover the plane's data and voice recorders. Claude Béchet will head the investigation.
Was it the pilot or was it the plane? We need to know.
Like the pilots of Flight 296, he also works for Air France as an airline captain.
Let's get to work.
Which is unusual for a state investigator.
At that time, I was still an airline pilot, and I was in New York when the accident happened, and they sent me a telegram to ask me to come back to Paris as soon as possible.
Apart from the flight recorders, investigators have a remarkable piece of evidence to consider. A high-quality video of the accident has been recorded by a French cameraman.
It was the first time we had a video of an accident, you know. Normally, an accident happens in the middle of nowhere, where nobody is there with a camera to film it.
The tape clearly shows the plane flying right at the trees at the end of the runway. It doesn't seem to be climbing at all. The cockpit voice recorder offers a confounding clue.
Takeoff, go around power.
30.
Get me!
It's clear the crew had no idea there was an obstacle at the end of the runway. Investigators are puzzled. How could a forest take a pilot by surprise? Béchet brings Captain Asselineau in for questioning about the flyover at Habsheim. They need to know what his plan was.
My intention was to carry out a flyover at slow speed.
As a qualified A320 pilot, Claude Béchet is familiar with the plane's capabilities.
Over the airstrip, and we go to Alpha Max.
Very good.
He sees nothing wrong with Captain Asselineau's plan.
It was not bad. Making a slow pass was well planned. And he seemed to me to be very open and very ready to help to work with the Investigation Commission.
Investigators turn their attention to how Air France prepared the flight crew for the airshow. They discover a memo setting out the rules for all airshow flights. What draws the attention of investigators is the minimum altitude Air France had selected for airshow flyovers: 100 feet. It was in violation of national regulations.
He should have been at 500 feet, as a matter of fact. But there had at that time a tendency for pilots who were making air shows like that to go a little bit lower and sometimes much lower.
Chief Investigator Claude Béchet now wonders if there were any other mistakes in the planning of the flight. He soon learns that Air France's flight division didn't start drawing up a flight plan for the demonstration until less than 48 hours before the airshow. An Air France employee had prepared maps of the airfield for the crew of Flight 296. Investigators find a serious problem. The forest around Habsheim airfield did not show up on the photocopies. The employee who had put together the flight package didn't have an opportunity to discuss it with the crew.
You were using an evacuation shaft?
While questioning Asselineau, Béchet discovers that the pilots were also given little time to prepare.
Happened then. Here's the flight package. Thanks.
That's highly unusual for an airshow.
My co-pilot told me, okay, we make a flight around Mont Blanc, and then we have to make 2 low pass of a small airport, Habsheim. Told me there is nothing special. So for me, it was a normal flight, a normal day.
That preparation had not been complete. and there had been no briefing of the crew by the staff.
Investigators then make an intriguing discovery at the crash site. They measure the height of the trees hit by Flight 296. They discover the average height of the forest to be only 40 feet. This poses an urgent question. How could an Airbus that was supposed to be flying at 100 feet hit trees less than half that height? It is clear to investigators that Flight 296 fatally deviated from its original flight plan, losing altitude before plunging into a forest. But only the black box data can help them understand how and why this had happened. Information from the A320's flight data recorder is recovered within hours of the crash. The device records information about 200 aircraft functions. It paints a detailed picture of how Flight 296 was operating in the final minutes of its journey.
Can be!
We could reconstruct the entire accident. We could live with the crew as the accident was happening.
Investigators make two striking observations from the data. The first is that Flight 296 suffered no mechanical breakdowns. The second is that the A320 followed a very different flight path than the one Captain Assouline had planned. Instead of maintaining a stable airspeed and altitude, Flight 296 had slowed down and lost altitude as it performed the flyover. As the A320 crossed the Habsheim airfield, its speed dropped to only 112 knots. That's about as slow as an A320 can fly. The plane's deceleration was so dramatic, it was even visible on the video. Michel Assouline was one of Air France's top pilots. Claude Béchet is hard-pressed to understand how he could have mishandled such a high-profile flight. Pressed further, Assouline explains how the trouble started.
You were using a navigation chart?
Yes, we had some difficulty locating the airfield.
Leave the highway to the left, don't we? No, to the right of the highway.
It's slightly to the right of the highway.
There's the airfield. You've got it, have you?
They spotted the airfield too late. So when they did, they reduced the power and they descended.
So they rushed their descent in order to get into position for the flyover.
And they were still slowing down when they reached the airfield.
That's the airfield. You confirm?
Affirmative.
But then another problem emerged. The spectators were lined up on a different runway from the one the crew was heading for. The crew of Air France Flight 296 is ill-prepared for their demonstration flight. In planning for the airshow, Air France only provided the crew with information for runway 2, Habsheim's only paved airstrip. But Captain Assouline sees the crowds aligned on a much shorter, adjacent grass field.
I was expecting a normal runway. At the latest moment, I saw that it was a grass runway.
Captain Assouline lined up with the grass strip.
I had no idea that at the end of the runway was a forest. For me, it was bushes only or something.
Okay, you're at 100 feet there. Watch it. Watch it.
Because they had to rush their descent, by the time Flight 296 got to the airfield, it was flying too fast. To lose speed, Captain Assouline kept the thrust on its lowest power setting, well below the setting pilots normally use for Alpha Max flight. But another serious problem was developing. The aircraft had dropped below 100 feet and was continuing to fall. And the crew didn't seem to notice.
I'm okay there. Disconnect auto throttle.
In a matter of seconds, the altitude had fallen to only 30 feet.
What was extremely clear is that airplane was flying at approximately 30 feet above the ground, regardless of any other data. This data was extremely important.
Takeoff, go, run power.
No airplane of that size or of any other size should make a flight path that low.
The data is clear. You were at 30 feet, not 100.
I believed I was at 100 feet.
Claude Béchet is still uncertain how the A320 ended up so dangerously close to the ground. Captain Assouline insists his instruments failed him.
Flaps 2.
Quebec November Hotel, I'm saying Fox Echo 984.
Okay. 984.
Captain Assouline was relying on his barometric altimeter. It uses air pressure to measure the plane's distance from the ground. It had to be set to local atmospheric pressure to be accurate.
Quebec November Hotel, I'm saying Fox Echo 984.
Okay. 984. Put in 9.
The cockpit recorder proves that the tower provided the pressure reading and the crew set their instrument. But Assouline insists the altimeter was giving him a false reading.
I tell you, the altimeter said the plane was at 100 feet.
Michel Assouline stated that the barometric altimeter was, in fact, to be precise, 67 feet out. And that is something that he claims led him to be flying at 30 feet instead of at 100 feet.
Investigators are skeptical. Assouline had more than one instrument to give him altitude information. The A320 has a second altimeter that uses radio waves to calculate the plane's distance from the ground. That altimeter displays the altitude on a digital display. But Captain Assouline claims it was difficult to read.
We could not use the radio altimeter because this radio altimeter is digital and nobody can fly by reading numbers. I tried that later on a simulator. I never succeed to do it.
But the radio altimeter has another way of alerting pilots.
I'm okay there.
A digital voice call-out.
Disconnect auto throttle.
But Assouline claims he and his first officer, Pierre Mazière, could not hear it.
Some people say, but you could have heard the radio altimeter saying 30, 30, 50, 40, 30. No, because at that time this aircraft was very, very noisy. And we have the headset. And we have demonstrated at that time that the radio altimeter warnings or the radio altimeter call-outs, they were not going through the headset.
Despite Assouline's defense, investigators are certain that the crew of Flight 296 mishandled a risky maneuver. Béchet has more questions for Captain Assouline.
What did you do when you saw the trees?
I did what any pilot would do. I tried to climb over them.
Investigators learn that in the final moments before the crash,
30. Takeoff, go, run power.
Captain Assouline applied full throttle.
When I was waiting for the engine to spool up, that I realized in front of me there were trees. And I was waiting.
But he claims the engines did not respond. And when they finally kicked in, it was too late.
I tell you, the engines did not come on when I gave it full throttle.
Captain Assouline's testimony raises a troubling prospect. If there was a prolonged delay in engine response, it could indicate a critical problem with the A320's turbojets. Captain Assouline is convinced the engines didn't respond quickly enough in the final seconds of the flight. He makes it his mission to prove it. He uncovers an Airbus document warning of a defect on the A320. It says the plane's engine speed could stagnate at low altitude, a condition caused by poor airflow. When this occurs, the engine cannot accelerate. But investigators can find no evidence of such a failure in any of the data from the plane.
30. Takeoff, go run power.
In the 5 seconds after Captain Asseline applied full power on the thrust levers, the A320's twin engines had begun to spool up. They reached 84% thrust, close to full power, just before the plane hit the trees.
When you put from idle to full power, you have the impression that nothing happens for a few seconds, and then the power comes. But that was normal, exactly as predicted by the certification.
Investigators are increasingly certain the engines on Flight 296 didn't fail. They find a novel way to verify the data. Video of the crash picked up the distinctive sound of the A320's engines accelerating. By studying that sound, engineers can determine how much power the engines were generating in the final seconds before the crash.
We were able to compare the RPM of the engines from that film and from the flight data recorder. There was nothing wrong with the engines, any of the two engines.
Why?
Chief Investigator Claude Béchet has a new headache. Captain Asseline is convinced there is a conspiracy against him. He cuts off all cooperation with the investigation.
Very well.
Investigation committee, I tried to cooperate with them, but I began to be suspicious. And the press, each week, the aircraft is good, the aircraft has nothing, pilot error, pilot error, pilot error. All that was a big, big, big cover-up, my opinion.
Captain Asseline begins a campaign to challenge the French investigation. He appears on British television to make a dramatic assertion.
When I pull the stick to up position, the flight controls, the elevator control go to down position. So on any aircraft, if you ask up, following the order of the pilots, the elevator control goes to up. And not that on that one, it went to down. Why? That would be the good question.
His accusations go to the heart of doubts about the aircraft. The Airbus fly-by-wire system had given the A320's computers too much control. Asseline's claim that the plane didn't follow his instructions is supported by data from the plane's flight recorder. The black box recorded every movement of the pilot's side stick controller. It does show that seconds before the crash, Captain Asseline pulled it back to get the plane's nose up. Investigators compare it with what the plane did in response. They make a perplexing discovery.
He's telling the truth. The elevator moved down.
In the final seconds before the accident, the pilots had desperately tried to pull up. The side stick controls the plane's elevator. Pulling back on it should raise the elevator and pitch the plane upwards.
30.
But that's not what happened on this flight.
One of the strange things about the crash flight, which became apparent when the digital flight recorder was analysed, was that during the last few seconds prior to contact with the trees, the pilot was dragging back on the stick as hard as he could, but the flight surfaces were moving into a position to put the nose down.
Captain Asseline believes the plane's descent triggered an automatic response by the flight computers. Asseline inadvertently brought his plane to within 30 feet of the ground with his landing gear down and his flaps extended. Investigators now wonder if the plane's computer determined that Asseline was landing and initiated the necessary steps to accomplish that.
As the plane leveled up with the airfield, it overflew a little copse of trees which took the radar altitude momentarily below 30 feet. That would have been sufficient to trigger the flight control system to enter landing mode.
It's possible that in spite of what Captain Asseline was commanding the plane to do, the computer brought the plane's nose down for landing. Investigators must try to determine whether the A320 overrode its pilot at a critical moment. They analyze the data from the flight recorder.
Stop it there.
But to their disappointment,
So was the plane in landing mode or not?
the flight data recorder can't confirm if the plane went into landing mode. The A320 systems are so advanced that the recorder can't track all of the plane's functions. Investigator Claude Béchet comes up with another way to find out. He replicates Asseline's approach to the Habsheim airfield to see how the A320 responds.
Okay, let's start the descent. Power to flight idle. Now put it into Alpha Max. That's it. Gently.
I replayed the accident, but on the longest runway in Toulouse.
Altitude, 40 feet, 35 feet.
We replayed the accident exactly what it was.
Béchet's plan is to descend to 30 feet, as Asseline's A320 did.
Now pull up slightly to level off. Hold it there.
Béchet wants to see if the flight computer puts the plane in landing mode.
Okay, now full thrust. Did you feel that? Alpha protection.
The test flight has triggered a nose-down response from the plane's computers, like the crash of Flight 296. But the plane hadn't gone into landing mode. Instead, the flyover had activated one of the A320's main safety features: stall protection. Due to a lack of airflow over the wings, flying slowly in a nose-high position can cause a plane to lose lift. The A320's computer has been programmed to bring the plane's nose down when it gets close to stalling.
This means that in theory, as long as the flight control system is in operation, the pilot cannot stall the plane.
Béchet concludes the flight computers did override Captain Asseline's command. But he believes that by doing so, it had prevented the plane from stalling and crashing just short of the tree line.
That airplane didn't stall and, let's say, landed on the trees.
The investigation into the crash at Habsheim is coming to an end. Claude Béchet prepares to deliver his verdict.
The conclusion of my report was that the airplane was too low, too slow, and with not enough power.
As far as Claude Béchet is concerned, the report is the final word on the Habsheim tragedy. The case, however, is far from over. The French justice system is moving towards a judgment of Captain Asseline. He is charged with involuntary homicide in the deaths of 3 passengers and faces the prospect of a long prison sentence. But Captain Asseline believes he has found evidence that will exonerate him. He is convinced there was a conspiracy to tamper with the plane's black boxes, to conceal problems with the A320's fly-by-wire technology.
There has been a cover-up with some funny recorders. That's the first point. The second point, they have been changing the content of the recorders.
It all begins, according to Asseline, at the crash site. An employee of France's Civil Aviation Authority is photographed carrying the A320's flight recorders from the scene. Those same black boxes are presented as evidence at Asseline's trial. But inexplicably, they look different.
I had a chance to see the black boxes held by the court. But when I see the state they're in, they're old boxes, full of scratches, dusty, with chipped paint. I think, wait, these can't be the boxes from the crash. The plane was new. They're not the right ones.
Captain Asseline hires a Swiss criminology institute to compare the two photographs. Its conclusion: they're not the same flight recorders. Captain Michel Asseline claims the black box data from his flight has been tampered with. But investigator Claude Béchet rejects the accusations as outrageous.
They were trying to prove that the tapes had been tampered with, which we could not understand because every recorder expert knew that it was physically impossible.
But there is one expert who believes the black boxes are suspicious. Ray Davis is a former head of flight recorder analysis at Britain's Air Accidents Investigation Branch. He has been hired by British television to review the French investigators' work.
It was a little bit of an eye-opener in a way, in that prior to reading the report, I had a totally different impression of the possible causes of this accident, whereas when I read the report, there were so many anomalies and questions raised by the report that my whole attitude towards the accident changed completely.
Davis discovers evidence that could vindicate Asseline. It raises questions about when the crew applied power to try to overfly the trees.
30. Takeoff, go run power. 30.
While studying the black box data, Davis comes across a curious inconsistency. French investigators had synchronized the black boxes with a transcript of air traffic control communications. Davis examines the last conversation the pilots had with the tower before the crash.
984. Okay, 984, put in 984.
It was recorded by both air traffic control and the plane's own black box.
Quebec November Hotel, I'm saying Fox Echo 984. Quebec November Hotel, I'm saying Fox Echo 984.
Ray Davis discovers a time discrepancy between the two recordings, amounting to a loss of several seconds. According to the black box data, the aircraft was 5 seconds from impact with the trees when Captain Asseline commanded full thrust from the engines. But according to Ray Davis's analysis, this actually took place 4 seconds earlier. This 4-second gap dramatically changes the calculus of the accident. It's the difference between a normal delay in engine response and a serious malfunction.
Asseline claims that on this particular occasion, the delay was more than he expected. And depending upon which side of the argument you come down at as to whether or not the 4-second delay in the digital flight data recording was real or not, then, you know, he's either an idiot or you know, he's right.
The French justice system does not believe that Asseline is right. After multiple appeals, Michel Asseline is convicted of involuntary homicide and sentenced to 10 months in prison. Still, the controversy over the black boxes and the missing 4 seconds lingers on. It promises to forever cloud the results of Claude Béchet's investigation.
The public opinion thought probably, oh, well, there was so much at stake, you know. It was the future of all European aviation industry, which was at stake. So they managed to tamper the tapes so they could blame the pilot and not the airplane. But this is just impossible.
The investigation into the Habsheim accident made several recommendations. It calls for passengers to be banned on all demonstration flights. It also calls for better reconnaissance of airfields by flight crews. And they want airline procedures to be reviewed to ensure they conform with official regulations concerning altitude. Michel Asseline went on to a career as a teacher and inventor in the aviation industry. He continues to appeal his conviction and has devoted much of his life to clearing his name. The tragedy at Habsheim would have little impact on Airbus industry. The A320 would go on to become one of the most successful commercial aircraft in history, selling over 750 planes in its first 10 years. And fly-by-wire technology would be safely adopted by a new generation of passenger aircraft.
Good night now.
Sundance 518, taxi across runway 24 left. Contact ground point 65 when off.
February the 1st, 1991. Los Angeles International Airport, LAX.
246 heading 270, contact Los Angeles departure. Thank you, US Air 1493. You're cleared to land 24 left.
Cleared to land 24 left, 1493.
Traveling at 240 kilometers per hour, US Air Flight 1493 descends towards runway 24 left.
What the hell?
I pointed to the aircraft and yelled, US Air is crashing. The aircraft was fully engulfed in flames.
But the full scope of this tragedy is far greater than anyone can imagine.
Mayday, Mayday.
At one of the busiest airports in the world, a Boeing 737 has just exploded in flames upon landing.
I think the thought process in the tower was, it was 1991, it was one of the first nights of the first Gulf War. And I think the thing that was foremost in our mind was maybe it was a bomb that went off on the aircraft.
As firefighters bring the blaze under control, rescuers begin searching for survivors.
About 5 minutes after the incident occurred, we got a call from an emergency vehicle.
Amid the wreckage, they have made an alarming discovery. One that forces everyone involved to re-examine every detail of the last 15 minutes. US Air Flight 1493 cruises towards Los Angeles International Airport. LAX is a central hub for international travelers.
Just confirm the visual approach for US Air 1493 is 24 left.
That's correct, US Air 1493.
For the approach, Captain Colin Shaw is managing radio communications. First Officer David Kelly is at the controls. With 89 passengers on board, the flight isn't quite full.
Well, I'd been on a business trip to Columbus, Ohio. I went from the business meetings to Columbus Airport and got on a US Air flight that was nonstop to Los Angeles. Planned a lot of good things and good times for that weekend.
US Air 1493. Expedite your descent through 4000 as much as practical, if you would. There will be traffic pass above you on the south side.
As the Boeing 737 nears Los Angeles, the approach controller tells the pilots to make a quick descent. They will need to stay clear of a flight passing above them.
Okay, I'll expedite through 4. US Air 1493.
Landing at LAX can be a challenge for pilots. The airspace around the airport is often thick with traffic. On average, a plane arrives or departs every 50 seconds. Each of its 4 runways handles both takeoffs and landings. Taxiways intersect the runways at dozens of locations. The airport can be a maze of stops and starts for pilots following instructions issued by controllers.
737, turn right 010, intercept 48.
You got the left side in sight?
Yeah.
We're out of 4.
US Air 1493. Thanks for your help. Contact Los Angeles Tower 133.9. Good night.
Good night.
Gear down?
All right. You gave 3 bells?
Yes, I did.
Perched 12 stories above the ground, tower controllers have a hawk's eye view of traffic coming and going from the airport.
It was a busy night. There was a lot of airplanes. We had numerous arrivals and departures during that time of the night, so it was a typical day.
Elliot Brann is the clearance delivery controller.
The primary duties of the clearance delivery controller is issuing the routes of flight and the flight plans to the pilots as they come out of the computer. A flight strip is printed out, so you get a piece of paper with the call sign, type aircraft, route of flight. I issue the clearance to the pilot, and then I pass the strips, the flight information, to the next controller.
Brann shares flight information with 4 other controllers. 2 ground controllers who handle planes moving between the gates and the runways, and 2 local controllers who are responsible for planes taking off and landing. Tonight, local controller Robin Washer is overseeing the 2 north runways at LAX, 24 left and 24 right. She uses the flight strips to keep track of flights departing and arriving.
US Air 23 taxiing to position and hold runway 24 left.
Position and hold 24 left. US Air 23.
246, you still holding short of 47?
46, affirmative.
All right, you're next. Skywest 569, taxi up and hold short of runway 24 left.
Roger, hold short.
$28.75, good night now.
US Air Flight 1493 is about 13 kilometers from LAX. The pilots configure their plane for landing.
Speed brakes. Still working for a living.
All right. Flaps are going 1.
Flaps.
Now the pilots radio the LAX tower for landing instructions.
US Air 1493, inside rolling.
Wings 5006, ground, tower.
Robin Washer is busy with other planes. She doesn't respond to their radio call.
Skywest 569, taxi to position, hold runway 24 left. Traffic will cross downfield.
Okay, 24 left.
Position and hold, Skywest 569.
Wings west 5006, tower.
At 2166, connect approach 124.5.
30, green lights to 10.
Gear, flaps, landing clearance remains.
Just 6 kilometers from the airport, the US Air jet still doesn't have the okay to land.
Sundance 518, taxi across runway 24 left. Contact ground point 65 when you're off the runway. Good night.
Captain Shaw contacts the tower for the second time in less than a minute. He needs Washer's permission to land.
US Air 1493 for the left side.
24 left.
246 heading 270, contact Los Angeles departure. Night.
But she's still focused on other planes.
Out of 1,000 feet.
Flight 1493 is now 1 minute from the runway. It's what pilots call short final.
Sometimes due to other priorities that take place, an aircraft might not get a landing clearance until short final.
Thank you, US Air 1493. You're cleared to land. 24 left.
Cleared to land, 24 left, 1493.
Looks real good.
You're coming out of 500. What the hell?
The US Air 737 has barely touched down. It erupts in flames and crashes through Los Angeles International Airport.
I saw US Air touch down, and as he got about third way down the runway at taxiway 45, the aircraft was fully engulfed in flames. The supervisor ran past me to pick up the crash phone and alert the emergency vehicles to respond.
Aboard the flight, sheer terror.
There was a tremendous crunching sensation, and there was this extraordinary shower of sparks that shot by my window.
Good God.
Rosa Reynoso is a plainclothes officer with the airport police.
We see the aircraft engulfed in fire. My partner and I were probably about 500 yards from it.
Alert 33, runway 24 out. Affirmative, alert 33.
The initial moments were very scary, very chaotic. I remember just thinking to myself, oh God, please get some more people out here. Get me fire, get me officers, get me somebody, because this is not good.
In the tower, there's no time to dwell on what's happened. Other aircraft are still coming in to land. Controllers must direct them to safety.
Wings west 5212, winds 240 at 8. You are cleared to land. Runway 24 right. Use caution. We just had an aircraft go off the runway in flames.
The cabin of Flight 1493 is filling with toxic smoke. Some passengers rush to a door at the rear of the plane.
I probably got 7 or 8 rows down the aisle, and then I encountered a cluster of passengers standing in the aisle, not moving. I thought to myself, there must be an opening in the front of the plane that allowed for this tremendous quantity of smoke to roll into the plane so quickly. And so I stumbled forward to the cockpit area, and there was tremendous fire on both sides of the plane. I said to myself, my gosh, there's no way you're going to get out of this airplane, David. You're trapped.
Outside, some have escaped the plane. Rosa Reynoso is the first emergency responder to arrive at the scene.
The fire was intense. It was very, very hot. I mean, almost singeing us.
She needs to act fast to help passengers away from the burning wreckage.
The passengers were trying to escape the plane from the emergency exit doors. However, the fire had engulfed the doors, so some of the people that were fine jumped out of the plane and into the fire.
More emergency personnel arrive within minutes.
Most passengers are jumping out of that door.
Some people were on fire. Some of them were scratched, cut up. Some of them had broken legs. It was pretty traumatic. And I think you just start operating on knowing that you have to do the right thing and try and save these people.
David Koch is still inside.
I suddenly saw a crack of light, and my God, it was a miracle. The crack opened up, and I suddenly realized that I had opened the galley door.
But now he faces another hurdle. He can't even see the ground through the fire and smoke.
And I said to myself, what the hell, and jumped out. I landed on the ground and then started crawling on my hands and knees away from the airplane. I had a great sense of guilt. Why did I not go back into the airplane and say, follow me? And I think if I'd gone back into the cabin, I might have passed out and fallen on the floor and died. And that's how I've come to terms with the fact that I got out but didn't help anybody else out.
As the search for survivors continues, firefighters make a stunning find.
This is Rescue 1. We've got a propeller down here in the wreckage.
The discovery of a propeller has horrifying implications.
There's 2 planes down here.
As soon as we found out that information, we started actively looking to see what aircraft, if any, were missing. So we started looking at the flight strips that were already departed, and then we looked at the ones that were still pending. And then we called the departure control, radar controller to find out which ones they've talked to in the last 5-6 minutes.
What about SkyWest 5569?
No, we haven't heard from them.
SkyWest 569, taxiing to position hold, runway 24 left.
Okay, 24 left, position.
And hold, SkyWest 569.
Staff can account for all of the aircraft except for SkyWest 5569, a Fairchild Metroliner bound for Palmdale, California. Emergency personnel find parts of the smaller plane strewn across runway 24 left. There were 12 people on board the flight. None have survived. What's left of their plane is crushed between US Air 1493 and an abandoned building near the runway.
My first thought was, oh my God, there was someone else under there, and we didn't even realize it.
There's even more loss of life on board the larger plane. 20 are dead, 2 others are mortally wounded. First Officer Kelly has survived, but Captain Shaw has not. The disaster thrusts LAX into the media spotlight.
America's runways, according to the nation's pilots, the most dangerous part of the flight.
In the months and years leading up to the crash, increasing traffic was becoming a safety concern at Los Angeles International Airport.
The most close calls, Los Angeles International Airport. 33 near collisions over the last 4 years. That's 1 every month and a half.
The accident confirms safety issues need to be addressed. The National Transportation Safety Board sends its GO team to LAX to investigate.
It was kind of a horrific scene. The front end of the airplane was impaled on the captain's side against the building. And with close inspection, we could see parts of another aircraft underneath.
Investigators can see that the two planes collided at an intersection on runway 24 left.
The scenario of the accident resulted in two planes being on the runway at the same time. The runway was occupied, and that's something that should never happen when a landing clearance is granted.
Reducing collisions on U.S. runways is a priority for investigators from the NTSB.
We had runway incursions on the most wanted list from 1990 here at the Safety Board, and it's a major concern for the whole industry. A runway incursion is simply when an inappropriate object is out on a runway that's going to be used for a takeoff or landing.
Some of the world's worst airline disasters have taken place on runways. In March 1977, on the island of Tenerife, 583 people died when two Boeing 747s collided on the runway. In January 1990, a Beechcraft King Air 100 was struck by a Boeing 727 attempting to land in Atlanta. Later that year in Detroit, another Boeing 727 smashed straight into a DC-9 carrying 44 people.
Runway incursions occur due to some failure in the existing system. Something has happened. Some directive has not been followed. Some inattention is present in the scenario of a runway incursion.
Which one of these planes was cleared for 24 left?
Investigators need to find out why there were two planes on runway 24 left at the same time.
One of the principal objectives was to immediately see if we could find out what error had taken place that would allow that situation to occur.
Part of that answer may lie in the wreckage. But 24 hours after the crash, the investigation is at a near standstill. There's too much fuel on board the 737. Crawling through the wreckage would be dangerous.
The aircraft had about 6,000 pounds, maybe 1,000 gallons of fuel on board.
How long is this going to take?
The Saturday was spent defueling the aircraft, and that's a very slow process. That took almost all day before the fire department could declare that the scene was safe.
With airplane parts littering the airport, LAX is running at half capacity. 2 of the 4 runways are shut down. That's causing chaos for travelers. When the NTSB team finally gets access to the wreckage, they're under enormous pressure to act quickly. They must gather all the information they need so the airport can be fully reopened. Their investigation has a dual purpose. They must figure out what caused the collision. They also want to know why so many passengers got trapped and died in the burning aircraft.
We're not sure what went on. We don't have a recording of it, but there were some altercations with people trying to get ahead of other people.
Making matters worse, one of the emergency exit doors is inside the plane, partially blocking the exit.
If you follow the instructions on the card, the exit card, it will tell you to throw that exit out. This did not take place, so the right over-the-wing exit was, I would say, partially obstructed by that large hatch.
The NTSB concludes that a reduced number of exit doors made it impossible for many of the passengers to escape. With no way out, they were overcome by toxic smoke as it filled the cabin. While some investigators analyze wreckage at the crash site, others focus on air traffic control.
Well, first and foremost, we look at the communications, then we also look at the procedures within the facility and how those are applied, and were they indeed followed.
To learn more, the NTSB collects the audio tapes of the controller's communications with the planes. Investigators wonder what instructions were given to the pilots in the moments leading up to the crash. They also want to know what the flight crews were saying during those crucial seconds. Did the pilots follow their instructions? The cockpit voice recorders should provide investigators with the answer. But then Bob McIntosh gets some bad news about the SkyWest Metroliner.
No voice recorder. Great.
We recognized, looking at the onboard equipment, that SkyWest 569 did not have a CVR flight recorder installed. And that was disappointing to us.
At the time of the crash, commuter planes were not required to carry cockpit voice recorders. This means the only SkyWest conversations caught on tape are radio communications recorded in the control tower.
K24 left, position and hold SkyWest 569.
The two cockpit crew members would have exchanged words, would have been listening to the air traffic information that was coming into their cockpit all the time, and we recognized that that was a valuable piece of data that we lost.
Using the air traffic control tapes and just one CVR, investigators try to find out which of the two aircraft in the collision was actually cleared to use runway 24 left. The answer will raise alarming questions about the safety of all passengers flying to and from LAX.
246, are you still holding short of 47?
The investigation into the deadly collision on runway 24 left focuses on Robin Washer's conversations with the two planes involved. Investigators begin with the smaller plane.
23 taxiing to position and hold.
Minutes before the accident, the pilots of the Metroliner waited for permission to take off.
SkyWest 569, taxi into position and hold runway 24 left. Traffic will be crossing downfield.
We use the tapes to try to visualize, like a local controller would, where the aircraft would be on the runway.
The pilots of the SkyWest Metroliner turned their plane onto the runway and stopped at intersection 45. They had to wait for another plane to cross the runway downfield.
Okay, 24 left, position and hold, SkyWest 569.
Okay, stop right there.
From the air traffic control tapes, the NTSB can tell that the pilots of the Metroliner followed all their instructions correctly.
All right, let's keep going.
Responsibility for the accident must lie elsewhere. Investigators probe the tapes further. They look at Washer's communications with the US Air pilots.
US Air 1493 for the left side, 24 left.
Thank you, US Air 1493. You're cleared to land 24 left.
A US Air 1493 was cleared to land on the same runway during the time that SkyWest 569 was still sitting in position on that same runway.
Cleared to land, 24 left, 1493.
SkyWest 569, right at intersection 45. How long's it been there? 1 minute, 7 seconds.
The air traffic control tapes reveal that Robin Washer instructed both the SkyWest Metroliner and the US Air flight to use runway 24 left at the same time.
Left contact, ground, point 5 when you're.
When we're examining the recorded voice communications, what we try to do is to put ourselves in the position of the controller. What would she have seen? What would she have heard? What would she have done?
Investigators need to know what Robin Washer was doing at the time of the crash. They look at the other flights that she had under her control.
Wings West 5006, taxi across runway 24 left.
They learn that in the moments before the collision, Washer began to lose track of some of those flights.
Is that for Philippine 102?
No, sir, hold short. Wings West 5006, taxi across runway 24 left.
Wings West 5006 was an aircraft that was on the north side of runway 24 left who wanted to cross to the south side.
Wings West 5006, ground tower.
And when she was ready to cross the aircraft, the crew did not respond.
Washer spent nearly a full minute of her time trying to re-establish radio contact with the flight crossing the runway.
Can I hear the rest of that exchange?
Wings West 5006, on frequency again. Change radio. Sorry about that.
They advised her they had inadvertently been on another frequency.
5006, you're back with me.
Yeah, we didn't mean to switch radios. We're on now.
And that created a distraction for the local controller.
Okay, I thought I lost you.
Sorry, we thought we lost you. We apologize.
Not a problem.
But investigators discover that that flight wasn't the only aircraft Robin Washer was fixated on in the moments before the crash.
Tower Wings West 5072 is ready for takeoff.
Wings West 5072?
With US Air 1493 less than a minute from touchdown, Washer hears from another Wings West aircraft, Flight 5072.
When Wings West 5072 called to say that he was ready for departure, it was obvious to us that she didn't understand who this aircraft was.
Wings West 5072, are you at 47 or full length?
We're at full length.
Okay, hold short.
Roger, holding short.
Investigators need to hear from Washer herself.
I couldn't find the flight progress strip.
They hope to learn why she didn't recognize a flight that was under her control.
I couldn't find the strip, so I asked my supervisor to help me. Francina, I need a strip for Wings West 5072.
She explains that as the pilots of the Metroliner waited on the runway for permission to take off, she was searching for another flight's progress strip. Before she could get back on track, US Air Flight 1493 crashed into the back of the Metroliner.
What the hell?
NTSB investigators now know that human error played a major role in the collision at LAX. Remarkably, when she cleared the US Air flight to land, Robin Washer simply forgot about the Metroliner waiting on the runway.
This situation that occurred is a situation that no controller wants to go through. You train your whole career for this not to happen. And when it does happen, it's, you can't even describe the feelings that you go through. A situation like this could potentially happen to anybody. We are all human.
After the accident, Washer left her job at LAX and never worked as an air traffic controller again. But investigators believe there are likely more causes to this accident than one person's fatal error.
Anytime that you do an investigation, it's easy to point the blame at one individual. What you want to do is to say, why did this occur, and what can we do to prevent a reoccurrence?
Answers to those questions begin to emerge as the NTSB examines the daily routine in the control tower in the weeks before the accident.
It was one of those, you don't know you have a problem until you have a problem.
It turns out another disaster was narrowly averted 7 months before the collision. A landing DC-10 flew just over an Airbus waiting on the runway to take off at LAX.
Los Angeles Airport has always been known as one of the #1 runway incursion airports in the system, and changes were overdue.
Controllers at LAX produced documentation showing that immediately after that close call, they alerted officials that the control tower was understaffed. They also explained that regions around the northern runways were invisible to controllers because their view was blocked by a light tower.
We went up in the tower, climbed the stairs, and asked the air traffic controllers to step aside while we sat in their chairs and looked out the window. The view that the air traffic controller was presented with had an obstruction, a light pole that produced a glare, and it was a light that lit up the airport ramp.
Robin Washer may not have been able to see the SkyWest Metroliner as it sat out on the runway. NTSB investigators look at other tools she could have used to detect the forgotten plane.
Surface radar is generally used during periods of low visibility. It is a tool by which the local controller, should they so choose, be able to visually confirm on that scope that an aircraft is indeed where it says it is.
Ground radar displays all aircraft and ground vehicles moving around the airport. But on the night of the accident, that system wasn't working.
You're holding short, is that correct, sir?
Yes, ma'am, we're holding short.
It was in constant out of service, in service, out of service, in service, and gave the management a lot of trouble.
The system was not very reliable, and we did lodge complaints to have it fixed and to upgrade the system as soon as we could.
Investigators learned that just 4 days before the accident, officials at LAX had formally asked the FAA to treat the failing ground radar with the highest priority.
The radar drive and some of the drive mechanism had some ring gears and spur gears that they had to go to machine shops and literally make that part because it would wear out on a regular basis trying to rotate the antenna.
We looked into this particular problem and learned that Los Angeles had been slated to receive a new system in 1988. However, that date had slipped, and at that time, they were not sure when they were going to get a new radar system.
With the ground radar system out of commission, and with her view of the runway impeded by blinding lights, Robin Washer's chances of discovering her error were slim. Investigators turned their attention to the cockpit of the US Air flight. They wonder why the pilots didn't see the Metroliner out on the runway and abort their landing.
Well, most of us in the pilot community would recognize that it's our job to scan that runway and find aircraft that might be out there or anything else prior to landing.
Like all planes, the Metroliner is equipped with lights to make it more visible at night. There are strobe lights on the wingtips and the tail, navigation lights on the wings, and a colored anti-collision beacon on top of the vertical stabilizer.
We were concerned about the SkyWest lighting and had to look at the flight operations manual, and we found that the operating procedure for that company was to turn on the strobe lights only after clearance for takeoff.
So no other lights were required? Okay, thank you.
The Metroliner wasn't yet cleared for takeoff. So the only lights that would have been lit while it waited on the runway were the navigation lights on the wings and tail, and the anti-collision beacon on the tail. NTSB investigators then use a helicopter to put themselves in the position of the US Air pilots as they were making the approach to runway 24 left.
We went up and we actually flew that final approach in order to verify what we thought might be the condition of obscuration.
They positioned a Metroliner on the runway in the same spot where the collision occurred.
And sure enough, we could not see that aircraft parked out there at spot 45 and 47. You just couldn't see it.
Looks real good.
The investigation determines the lights on the Metroliner were the same color and brightness as the runway lights. The plane may have been all but invisible to the pilots of US Air 1493.
You're coming out of 500.
The anti-collision beacon in particular would have been lost in a sea of lights. When the National Transportation Safety Board releases its report, controller error is determined to be a cause of the runway collision.
We're in the business of determining why something happened. You may call it a cause or causes or contributing factors, but our job ends when the next accident is prevented.
Preventing accidents on the runways of LAX would prove to be a much greater challenge than investigators could imagine. The collision between US Air Flight 1493 and a SkyWest Metroliner alarms the public. The accident seems to prove that controllers cannot safely handle the increasing traffic at Los Angeles International Airport. The NTSB investigation points to Robin Washer's failure to maintain awareness of the flights under her control as one cause of the accident. But the report also points to a failing system in the air traffic control facilities at LAX. In the months and years following the accident, improvements are made to air traffic facilities in an attempt to make the airport a safer place. The failing ground radar system is finally replaced with a newer model.
Today at Los Angeles Tower, we have the newest system out there. Each arrival or departure they're taxiing on the taxiways or on the runways have a call sign and type aircraft associated with it, so you have positive identification of all aircraft at all times.
New policies governing the way flight progress strips are handled in the tower are put in place. Ground controllers now organize the strips before they make their way to the local controller. The extra set of eyes reduces the local controller's workload. 5 years after the crash, a new air traffic control tower is built at LAX. The tower is 16 stories higher, 3 times larger, and offers controllers clear, unobstructed sightlines. New regulations concerning aircraft lighting are also put in place. It becomes mandatory for pilots to turn on all their lights before they move out onto a runway. But despite the improvements, the rate of runway incursions at LAX only goes up.
Throughout the 90s and even into the 2000s,
I would describe it as a common event. LAX certainly was one of the worst airports we had for a number of incursions.
10 years after the accident, more serious runway incursions were happening at LAX than at any other airport in the United States.
They had double-digit runway incursions and serious runway incursions almost every year. And in fact, in 2007, they actually had 21 runway incursions.
In an attempt to reduce the problem once and for all, the Federal Aviation Administration begins work on a new system of runway lights to keep planes apart on the ground.
Runway status light system is a series of runway entrance lighting that we put at taxiways or takeoff hold lighting that we actually put on the runway itself.
The system is fully automatic. It uses a series of red lights embedded in the runways and taxiways. The lights warn pilots if there is conflicting traffic.
The runway status lights illuminate red, tells a pilot that it is unsafe, or a vehicle driver, that it is unsafe to either cross or enter that runway. And it triggers because there is an aircraft landing or departing. There's some other traffic on the runway. The runway status light seems to be one of the most effective systems we have for preventing runway incursions, and certainly the serious runway incursions.
In April 2009, the technology was installed at Los Angeles International Airport. Prototypes of the system have also been installed at Dallas, Fort Worth, and San Diego. By 2011, runway status lights will be a key feature at dozens of airports across the United States.
The equipment we're using at Los Angeles Tower today is much better than the equipment that we used back in 1991. It's been upgraded, it's much more reliable, and it gives the controllers the tools they need to make sure that the runways are clear and to keep the aircraft moving.
Though new technology can never guarantee 100% safety, the improvements at LAX have restored public confidence in the airport, even among those who survived Flight 1493.
I spent a couple of days in intensive care at a local hospital, and I had nightmares, by the way, following my release from the hospital for quite a number of days. But I'm doing fine now. I have no problem with getting on airplanes and flying, and I've got great confidence in the airline system.